Okay, we're going to start with writing the equation given the graph. Now the asymptotes are here, so I'm just going to go ahead and highlight them so I can see them. They usually are dotted lines, but because I'm using a marker, I just made them solid. They're a little bit easier to see. And I'm going to label them 1, 2, 3. X equals 3. Y equals 2. And it looks as though I've got 2 points that are labeled. I'm just going to write them a little bit darker. So we have the point 4, 0. And this one is 0. It's 2.6 repeating. 2.6, 2 2/3, 8/3. 8/3. Thank you. Okay, 8/3. That's just so that you can see the points from your seat there. Okay, write the equation in transformation form. So I'm going to start by writing the AHK format. And based on my diagram, I'm going to try to pick out my transformations. And so I look at the center of my graph. The center is where the asymptotes cross. Right 3 up 2. So I've got my H and my K. This is right 3 up 2. Right 3 up 2. So I'm going to put my H and my K in there. Your A value. You have always got 2 choices for your A. You could look at the count values and try to estimate or approximate or count what that is. So I'm looking at it. Well, you do know it's negative. It is negative because look, I'm in quadrants 2 and 4 instead of 1 and 3. Yes. Okay. And I'm looking at it. It goes over 1. It's supposed to go down 1. But instead it's going down 2. That means the A value is negative 2. Same way your counts work for every other graph. You can just look at it and pick it out. Now I'll do it algebraically. Okay, so we have 2 choices. Look at those 2 other points that are listed. Pick one of them, substitute, and solve for A. 0 equals A. 4 minus 3 plus 2. Right? I picked the point 40 because I didn't feel like plugging in a fraction. Right? Doesn't matter. Okay, I'm going to minus the 2. A over 1. Okay, yeah, A is negative 2. There's your answer, right? How do you find A? You substitute and solve, or you use your count values. Y equals negative 2, X minus 3 plus 2. Okay. This one was given a diagram. The next one is given a verbal description. Yes?
What do you mean by count value?
Okay, so for our parent function, I'll jot the counts here. Negative 1, negative 1. I'm not going to write the 0. I'm just going to dot, dot, dot. That means I've got an asymptote right there. Okay? 1, 1. Because my parent is 1 over x, so those are the values I get. Every time you go over 1 from your center, it can tell you the A value. In this particular case, when I go over 1, I went down 2. Well, the only way to change those is to multiply by the A. How do you get from 1 to negative 2? You multiply by negative 2. That's the A value. Okay? All right, so let's try number 4. Rational function with a vertical asymptote at 2 and a horizontal at negative 3 and an x-intercept of 3. We could sketch a picture. 1, 2, dot, 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 dot. 1, 2, 3, dot, 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 dot. An x-intercept of 3. Okay, When I told you about plotting points, you only need 1 point per branch. With my point in the top right quadrant, it means that the branch is in the top right quadrant. So draw the shape, right? There's only one shape in the top right quadrant. Question?
Yeah. So are we always going to have to draw it out?
No, I'm just giving you a visual to go with the verbal description. You don't actually need the picture to write the equation if I list out the information for you. It's just, it's good. I mean, everything's connected. It's nice to have different ways to look at the problem. Okay? Now, I'm going to add some grid lines here very lightly because the grid lines help me determine my count. My A value is positive 3. Positive 3 for my A value. Here's my center. Over 1, up 3. It was going to be 1, 1, but I had to multiply. Positive A value because I'm in the top right quadrant.
So, does that mean the A value would be 3?
Yes, it does. So Y equals A, H, K. Vertical asymptote, X equals 2. Horizontal, Y equals negative 3. Now I gave you a point. Means I gave you a way to find the A value algebraically, but you can do it graphically. We all have strengths. Pick the one that works for you. X-intercept, just make sure you write it as an x-intercept, right? 3, 0. Yes? We're going to do it algebraically next. Okay? So I'm going to take my x-intercept, and we're going to plug it in and solve for A. And then I'll show you again on the graph. So 0, A over 3 minus 2 minus 1. So we get add the 3 over.
Wait, so 3 is the A, right?
Yeah. Do you see it now? 0 and 3. And then I added my 3 to the other side. So I get an A value of 3. So you can do it algebraically or graphically. When I did it graphically, I was looking at the center of my graph. Okay? Let's highlight those asymptotes. Compared to the center, the 1 point that I have here, okay, look at how far over and up the point is. It's supposed to be 1, 1, but it was 1, 3. Okay.
I'm not allowed to work on 4.
So A equals
So yeah, A equals 3, which we knew 2 ways. And so I would go back here, seeing as how, right, you guys have got pencils. I have a pen, so I'm just going to white it out. I'm just going to put my 3 there. And, right, there's my answer. Okay. This is the beginning of the coolest question today. Beginning of the coolest question. Write the equation in transformation form. That's A, H, and K. I need to convert this. I need the vertical asymptote. I need the horizontal asymptote. I need the stretch. None of which, I might be able to pick out one thing. What's the one thing you think you can pick out from this equation that's going to match over here? Not the stretch, deceptively, but it's not the stretch.
The X plus 1.
The X plus 1. Yeah, the denominator is actually not going to change. The stretch is deceptive in this case, okay? Because it's not 2, right? The stretch is not 2. But the asymptote, dividing here, -1 makes it undefined. -1 still has to make it undefined. The vertical asymptote can't change. Well,
You could
You could take out a 2 from the numerator, but it doesn't reduce. You can divide them, actually. You can divide those two things. Think polynomials, guys. This is a ratio of polynomials. Can you? Actually, I'm going to write it over here. 2x minus 6 divided by x plus 1. Does anybody remember how to do polynomial division?
Factor it out, right?
You could, but the 2 doesn't reduce. How do I divide two polynomials? Wait.
You have to multiply it by the x minus 1.
By the conjugate.
By the reciprocal.
No, not there.
Conjugate.
Nope, you're saying the wrong words.
Reciprocal.
Nope, 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 nope. Synthetic division. Yes. Okay. What you were mentioning were ways to rewrite your fractions that have radicals in the denominator. Okay, so let's set up our synthetic division. Okay, right? Top divided by the bottom. Here we go. 2, negative 6. I'm just putting the little x up here to remind me where those coefficients are coming from. Okay? And negative 1 on the outside. Synthetic division is nice because it's meant for linear factors. Okay, the 2 comes down. I know, what makes Algebra 2 so much harder than Algebra 1 is this is now Unit 6, and that's a skill from Unit 4. And I do expect you to remember that you can divide with it. Okay? Negative 2 minus 8. Okay? So, linear divided by linear. The 0. Yep. Can I not add? No, I'm okay. What's negative 6 minus 2? Yeah? Yeah, no, we're okay. This is it.
No, I mean, he was combining the two.
Got it. Okay. What am I going to start with?
2.
You decrease the degree by 1. And so this is going to be a number, and this is the remainder. Okay. So we end up with
2 minus 2 plus 8. No.
okay, which is not really the right format, so I'm going to switch it around because I prefer to look at it in this format if I'm going to graph it. And so,
Wait, I'm confused. Why is negative 8 going over the
because it's the remainder.
Oh, okay. Yeah, that's a good joke.
Oh. Okay. This is negative 3 for my vertical. Okay, we get x equals negative 3. My HA is y equals negative 1.
Do we always have to state the answer?
I will usually ask for them, but on homework, I would just draw it. It's really tedious to write everything out. So just make sure that it's clearly shown on your graph. Okay? I was just about to say, I was like, just get a good picture so you can read everything. Okay, my A value is negative 2, so that's going to make it reflect. So my quadrants are going to be top left and bottom right. So it's going to go here. Here and here. Luckily, I already see the x-intercept plotted. Cool. I already see the x-intercept. Okay. Y-intercept. I do that one first because it's pretty quick to solve for that. Negative 2/3 minus 1. So that's minus 5/3. My x-intercept because it's on my graph, I'm just going to write it in, but I would substitute and solve for it. Okay. We're going to do question 2, so you can check your work. To speed it up, I'm just going to start drawing it, okay? Vertical is x equals 0. Horizontal is y equals 2. The a value is -2, so it's actually going to be very similar shape, just centered somewhere else. Okay. So my VA, my HA, oh, my y-intercept, there is none. Look at that asymptote. There is no y-intercept. X-intercept. This case, I'll show you what solving for it looks like. So I would subtract the 2, cross multiply, cross multiply correctly, and divide. I get x equals 1, which I actually already had plotted on the graph, but that way you can see what the algebra looks like. Plug in the 0, add, cross multiply.
Do you really need to do all that? What the hell? The x-intercept?
No, you don't, but I wanted you to see the work just in case. Right? If it weren't an integer, you would have to solve for it. Okay. Guys, bring it back.
Bring it back.
Okay. Here you go. You're adding them up. Number 1. Common denominator. Common denominator. -2 plus 2x over the common denominator, but standard form means put your degrees in order. So I'm going to put the 2x in front. That's it. Don't do anything. Do not reduce. You just put them together. Do not try and reduce. Nothing does reduce. Right? There's a common negative, or there's a common 2 factor, but nothing reduces. So leave it. Okay, last one. Okay, so -2, +3. Oh, no stretches. That's easy. Look at that. No stretches. That one should be really quick. Left 2, up 3. A value 1. Okay, let's add them up. When I'm adding fractions and I have just a number, I put it over 1 so that I can see where the denominators and the numerators line up. Okay, this is me doing a common denominator. Uh, 3x plus 6. 3x plus 7.
Wait, where's the 7?
1 plus 6. Okay. Here's your question. We have 5 minutes to answer it. Okay, we're not going to do the last page in your notes, but I do need you to answer this question. Okay. You have a conclusion here. You're going to have to do a little guess and check and see what connections you can make. How can you find the HA? That is the horizontal asymptote. By looking at standard form only. That would be the boxes we just put over here. The whole second half of learning to graph is standard form, right? We started in transformation form, but then we're going to look at standard form. So this is your first attempt at making some connections at how to find these quantities. So hold on, looking at standard form only. Do you have an answer?
Yeah.
Yeah.
Ooh, yes? Okay. All right.
I don't know how like how.
X plus 2 is to the left 2. The denominator is translation still. And then
Okay, I like it. The denominator is still a translation. It's still going to be left 2 for the vertical. But I'm asking about horizontal. From standard form only.
the coefficient of X.
Pretty close. Yes. I'd say you're like really close. Only because the example, you need like one more example to describe further. So I'm going to say yes, right?
Yeah, I mean like kind of what you said. The coefficient that multiplies x in the numerator.
Okay, so I'm going to highlight my asymptote over here. Okay, and here's your leading question. How do you find end behavior for polynomials? You look at infinities. Guys, this is a ratio of polynomials. How do you do end behavior in polynomials? What do you look at?
Slope.
Arrows. What do we look at to find the arrows?
Oh, sign.
The sign of what?
Negative, positive,
Leading coefficient.
Okay, there it is. You look at leading coefficient and degree. So I'm going to highlight the leading coefficient and the degree of both the numerator and the denominator because it's a ratio of polynomials. So look at both of them. How does negative x over x reduce?
Negative 1.
So you don't even need transformation form. That is true. I mean, it's useful. Don't get me wrong. But you don't necessarily need to convert it. Okay? You divide the leading terms because that's how you find end behavior of polynomials. And we divide them because we have a ratio of polynomials. Look at this. 2x over x. Oh, divides to 2. Divide, what did we do? We actually did division in our notes? Yeah, okay. What about the next one? 3x over x. 3.
So how would I
Y equals 3. Okay, guys,
talking about like on the bottom.
your homework, okay? Your homework is worksheets 1 and 2, which you've already started. Even. So you've already done part of it. You need all of worksheet 1 and 2, evens, and I would like you to do the back page of this warm-up, okay? Just the 4 through 6. Just 4 through 6,
And then
so that way we can start with our next conclusion. Tuesday? Like Tuesday the 19th? No, the quiz is not Tuesday. Maybe Wednesday. Whenever I feel like we finish what we're doing. The rest of worksheet 1 and 2, evens. But then I want you to do just 4 through 6 on this one. And that'll be like our warm-up next class. Oh, planning, how I miss you.